We're in section 4.6. We're going to do example 2. Still working with triangle congruence theory here, and we're using something called CPCTC, which is corresponding parts of congruent triangles are congruent. And I had a class a couple of years ago, because it's so hard to say this very fast, they call this cupcake. So that's what I had written in my book, and it just made me giggle because it just flooded back memories of when I taught this class and those girls telling me, we just want to call it cupcake. It's just too hard to say, and that's just what we called it. So in example 2, we're going to kind of change gears just a little bit. This time we're going to do a flow chart, okay? And what they want us to do, they've given us some information, and we'll doctor it up in just a second. And they want us to prove that angles A and D are congruent. They want us to prove angles A and D are congruent, okay? They've already marked with the tick marks. Segment AB is congruent to DC. What they didn't mark was angle ABC, we'll put 2 arcs here, is congruent to DCB. Okay, so I'm seeing, a potential here. We can't use this as part of our justification for why the triangles are congruent. That's our end product. Once we prove the triangles are congruent, then we'll be able to use cupcake to show that A and D are congruent. Okay, are you following? Because I'm hoping that that makes sense to you. Okay, so A and D, we haven't proven them. This is our question mark. This is what we're trying to get to and to prove that. So we got to find another way to prove that these triangles are congruent without using angles A and D, because we don't know anything about angles A and D. Okay, so what I have marked here, the tick marks for this side, and then the 2 angles here are congruent. We know that because that was given. And then notice that the triangles, if you look at this big triangle here, okay, so notice that side, I'm going to kind of darken it, and then the other triangle uses that same side. Look at that, okay? So notice here that BC shows up in both triangles. So we could use side, angle, side, side, angle, side. That's how we could prove that our triangles are congruent. Once they're congruent, then we can prove that A and D are congruent because of cupcake. All right, so let's do our flow chart. I think we can do a pretty easy flow chart. So the first thing we're going to put down here is that segment AB is congruent to DC. And we're going to put underneath that, well, that was given. We're going to put here angle ABC is congruent to angle DCB. Okay, that's given. Now, we're not going to draw arrows connecting those two because one does not lead to the other. They are separate entries, and so we don't need to necessarily do that. And then the third entry I'm going to put here, I'm going to say segment BC is congruent to segment BC because of the reflexive property. Okay, now these other two don't need arrows pointing from one to the other, but what we're going to do is we're going to point all 3 arrows, all 3 boxes are going to point to this box right here. And this box, now we can say beyond a shadow of a doubt that triangle ABC is congruent to triangle DCB. And the way we can say that is, well, side angle side. And then because we've proven that, this leads us to the next conclusion that we can make. That means angles A and D are congruent because a cupcake. Okay? So you don't use cupcake until after you've proven the triangles are congruent. That's essential. That's essential. I think I made a little bit of a mistake back on the reflexive. I think I should have written BC is congruent to CB, because they do reverse because the triangles are backwards from each other. So I apologize for making that little error for you. I didn't mean to mess you up on that one. All right, now I'm going to give you this next one to try. Do a flowchart for me and prove, using your flowchart, prove the two triangles are congruent, and then you'll be able to prove that PQ is congruent to PS, and you can use cupcake after you've proven the triangles are congruent. So do the best you can with that. I'm sure you're going to do a great job. Bring your questions to class.